Hello, everybody. It is 12:47 p.m. Central Time on the 10th of March, 2021. It's Wednesday here in the United States. Hope you're doing well. We are here to talk about seismic events. If you don't know where you're at, you're on the Earthquake 3D live stream. And I just turn on a display capture so you can see what I see here a little bit better. And new people, just quickly, I always explain at the start of my updates, the earthquakes that are raised high off the globe are deep down into the earth. And the deeper earthquakes we pay attention to because they lead to shallower, larger earthquakes, usually in between and next to where the deep earthquakes are happening. Now, we expect the deep earthquakes to happen in certain forecast locations. We put letter Ds on the map to signify where we look for new deep earthquakes to take place. So you see where our Ds are. We have a D over here at Fiji, two sets of Ds at Indonesia going into Philippines, another one up here at Japan, and another one up here at Kamchatka, Russia. Furthermore, all the way over here in the Mideast, just north of Afghanistan, we have a letter D, and on the other side of the planet, we have a letter D down here in South America, right at the Argentina, Bolivia, North Chile border region. Just remember where those Ds are because in the past 48 hours, each D has been hit by a new set of deep earthquakes across thousands of miles. Now, what I want you to think of these deep earthquakes as more like leverage on the underside of the plate, like a lever on the underside of something. Another way to look at it would be like this, which I think a standing wave is focusing in on itself under the curvature of the plate and hammers in at a singularity or at a point where the combined force of the whole wave coming in over hundreds, if not thousands of miles underneath the plate focuses in and hits the underside of the plate, or at least down below it, in the asthenosphere, where this all takes place. And then it hammers into the underside of the plate and comes up through the plate, and that's where we see our deep earthquakes. Then spreading out between our deep earthquakes, something else apparently is happening, which is a standing wave. After this deep earthquake activity takes place, then this starts to happen, where the waves combine and they spread out again across thousands of miles. This is in a laboratory, of course, in a perfectly rectangular wave tank where this end here or this end down here, or both of them, can push in towards each other or pull out away from each other. And when they push into each other, that's pumping energy into the fluid. And when they push together, it creates what's called a standing wave. And that standing wave, instead of getting chaotic in the tank with a bunch of jostling waves, they become organized, and the amount of power you put into it dictates the size of the wave in the tank. So you pump this thing more full of energy, and the waves get bigger. Now notice how they're the same size. And when they move through the tank, they fill in each other's previous middle point. The peak goes into the crest, or the crest goes into the trough, or the bottom of the wave. And then we get back here. We have a spread of the same sized earthquakes spreading out between our current deep earthquakes. We have 2 more days to go in my watch, going down to New Zealand and over to the west, as far west as New Caledonia, but mainly right here in the Solomon Islands, for the potential of 7.0 plus activity to break out between these two current sets of earthquakes. So far, all that's happened right in the middle, a new 5 hit this morning. And I would call that the middle point between all the way up here with all the activity going. Here, let me show you. Again, we go far up to the north, actually, into the central Kermadec Islands. But here, again, there's our earthquakes to the north. Here's our earthquakes to the south. We have a deep earthquake in between and a 5.1 sandwiched right in the middle. That's 2 magnitudes under so far. But nonetheless, the middle point was filled in, and all the middle points were filled in with 5s. Going over to the west, 5.3, 5.0, 5.1 striking at the middle point between our other sets of 4s. This is all centered around where there's a few volcanoes that at least have not erupted in a few months. Aussies, you got hit by a 3 down here at southwest tip of the continent, east-northeast of Perth, and activity is spread up to the north, going up into Malaysia, which is right in here. It's somewhat more rare to get the activity over here on the western side of our letter D, but New deep earthquake right next to our letter D. We're 2 days more to go in the watches over to the west as well. As a matter of fact, all the watches go for 2 more days. And we wait till the very last day, day 7, at midnight. Okay, so that stands for Indonesia as well, where we had a warning going at Bali, and a bunch of earthquakes have struck over to the west and over to the east, and I haven't even checked the Volcanic Ash Advisory Center yet. So let's get over there and take a quick look, shall we? Let's go over to the VAAC and see which volcanoes. Whoop, whoop, up! 8,000 foot high blast at Papua New Guinea, right in the middle where I just showed you. Hold on, we're going to go wait before we go anywhere else. Right here. See where all 3 sets of rings overlap. Bagana. I just mentioned over here that all the volcanoes have gone quiet for months. Well, now one's back, right where all 3 sets of rings overlap. 8,000 foot high blast. Now that's also on the plate boundary, which I'll show you in a second, but Bagana volcano over in Papua New Guinea. Okay. Something's going on right in the middle. It's spreading. The energy is spreading from that big 8 a few days ago. By the way, if you don't know, a huge earthquake happened a few days ago. This big 8. Plus a bunch of 7s. You see there's 7s mixed in, but the 7s hit first, actually. So first the 7s hit, then the 8 hit. But okay, right in the middle we've got major volcanic going on. Down the list we have Sanjay, Dukono, Reventador, Raung, 13,000 foot high blast. Veniaminov still going, but it's just low level. That's up in Alaska. Bagana again. Sanjay, Sinabung, 11,000 feet. That's over in western Indonesia. Let's carry on. Anybody else? I mean, that's enough right there to have a new one on the list right in the middle of the hot zone. Bagana again, 8,000 feet, continuous emissions throughout the day today. And it hasn't been on in months. It really hasn't. Okay, Ibu is on the list. They haven't been on the list either. Wow, okay, so Ibu last night. Anybody else? I'll show you where these all are if you don't know where they are. Let's go back over to the plate boundary map first. USGS plate boundary map. First of all, Bagana volcano over here in Papua New Guinea. That's the interesting one. Over to the west, we go all the way over here. We have Mount Sinabung, which is up at the northwest tip of Sumatra, Indonesia, right along the plate boundary here. Going over here, we have Mount Ibu, where this whole mess comes together, all 3 sets of lines. That's right in Indonesia. Well, just seeing those right there alone are a sign that something's going on. Oh, and Raung volcano. I believe it's right down in here. East Java. I believe that's where it is. Going up to the north, Sakurajima's going in Japan. That's at the south tip of Kyushu, right here at South Japan. And Suwanizajima's going right off the coast. So 2 volcanoes in South Japan going. As we go far up to the north, we get all the way up here, and it's gone quiet pretty much. Up in Kamchatka, again, Shivelush, Kluchevskoy, Bezimiani. We used to see those go almost every day. And then now it's just hush-hush, but that's right at the bend of the plate. But we get over here, and Veniaminov volcanoes out in the peninsula of Alaska. Okay, so we're going from here up to here to Japan, and then going over to Alaska. That's where our main center of volcanic activity is taking place. On the other side of the plate, we have Popocatépetl in Mexico. We have Fuego and Pacaya in Guatemala. So Mexico's volcano is about right here. And then we go down into Guatemala, of course, and that's where the other activity is in Central America. We skip all the way down here, and we have Reventador and Sanjay in Ecuador, both erupting. We go further down to the south, and Sabancaya is erupting down here in South Peru. Nothing down in Chile. No eruptions in Chile. So it's somewhat quiet, volcanically speaking, across the East Pacific and the Central West Pacific as far over as Papua New Guinea. Then once we get to Papua New Guinea, picks up. Why? Well, Papua New Guinea is just west of all of our deep earthquakes. So that's where our volcanic is taking place, right around where all of our deep quakes are also happening. As we go over to the west, the Indian Ocean was struck by a 5.0 earthquake. You see it listed as a 4.9 here, but it's right on our arrow. And if we go over to the USGS map, let's go over to the Indian Ocean. There's the quake. Look where it is. It's on the stair-step fracture zone that goes up to the north into the Gulf of Aden, and the number 7 shaped Carlsberg Ridge, all the way up here to the north, south of Iran. Here's the Gulf of Aden. And then over to the west, there's nothing on the US GS map, but our arrow goes right across the middle of this parentheses shape here, which is a series of undersea mount volcanoes that go up to Piton de la Fournaise volcano. But over to the west, look where it goes. It goes over to Africa. Well, why does it go over there? Well, there's a push that comes across from Indonesia. Goes right across the Indo-Australian plate boundary and hits that stair-step fracture zone that the USGS has on their map. Some of the energy goes to the north. Some of the energy goes to the south. And a predominance of the energy tries to maintain momentum and goes straight into Africa. Now, here is Mayotte Island. It just got hit the other day, and it hadn't erupted in 3,000 years, 2,500 years. Mayotte Island here, the southern island. And it started to show seismic activity a few years ago. We started to notice that. I made videos on it. People said I was fear-mongering, talking about it. And then it erupted after 3,000 years of silence. Now, it erupted out in the ocean, thank God. Energy transfers from Indonesia across the Indo-Australian plate boundary all the way over to the edge. And then it goes over into Africa, tries to go up north, tries to go down south. Equally, tries to split. Now let's go over to Africa, because look what happened all the way over here. We're still moving. This is from the other day. There was a smaller earthquake. Now there's a bigger earthquake here. It's a 5.4. Gabon. We went and looked it up earlier when the first earthquake struck a few days ago. And I'll show you what it has in common with the other locations in a second. This is super rare. And I mean rare. We're out in the middle of the jungle. Look at that low resolution imagery. Absolutely fabulous. We're not going to get a good view of anything on the ground, but overall, look where we're next to. Here we go. Now look what goes out into the ocean. They don't have it really marked as a current volcano, but just over to the west, almost parallel to the earthquake, we have Sao Tome. Sao Tome is a roughly conical island in the Gulf of Guinea that rises from a depth of 3,000 meters below sea level. The south and west parts of the island are more dissected, and dramatic phonolitic and trachytic spines, I don't even know what that is, at least the phonolitic, rise vertically out of the rainforest. What? Oh, right there at the island is still considered the rainforest, of course. Most of the lavas erupted over the last million years and are basaltic in composition. But there's a whole line of them, and it goes right up and goes up into the arm or the armpit of Africa. And there we go. I mean, it's a indisputable line of undersea mounts, and that's what all of these are. Every single one of these is an undersea mount volcano, some of which have come up above land. So we're directly next to that on the edge of the African plate, which you can see the craton as it goes up and into. We have a basin versus lowland, lowland versus highlands. But it's, again, you can see that bend in the plate. It's right on it, on the edge, over to the west, just like we would expect on any other plate. So is it volcanic related? No. It's edge of the craton related. The volcanoes are the weak point out over to the west. So where's the energy coming from? Well, it came from the push that came over the past several days, going to last week. But the push over the past several days has been indisputable. We have a big amount of movement coming out from the West Pacific, and look what else happened. Our warned area at the Myanmar-China border region was directly hit. Check it off the list, but it's about a magnitude under what I'm expecting. I was expecting 5-ish, going to near 6. Instead, it's 4-ish, going to near 5. So upper 4, bunch of other 3s, breaks out all the way around here. And let me show it to you on the USGS map. Let me show you where we warned versus the spot that was hit. We had warned right here at the bend in the plate boundary east of Nepal at the Myanmar, India, China border region. And the spot that was hit was the India, Myanmar, China border region. It's the only spot to be hit in the past several days. It's been quiet for 4 days, or 3 days. Not a single earthquake reported out of the whole area, the whole continent. And then now today, boom, 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 right in the warned area, a magnitude under expected. But it's moving. There it is. Middle point hit. Check it off the list if you're watching the locations that we're naming. Now, as for the magnitudes or the power behind it, if I'm off by magnitude, so be it. They said it was impossible to know a location that was going to be hit or in a time frame or anything, or within a magnitude. They said it was completely impossible, so if I can get it down to a magnitude and get the right location, I'm happy. Over to the west, Iran, high and dry, still no seismic activity of any significance being reported out of the whole country. But on the USGS map, you can see the plate boundary right here in Iran, southern edge. We're watching, we're waiting. It could go into the 6th level, just like I was looking over here. But if I'm a magnitude under there, stands to reason I'd probably be a magnitude under in Iran too. I hope for the best. Over to the west, where I'm not counting it out until the end of the forecast, guys. I never count my chickens before they hatch. At the end of the 7 days, we will address it then. Europe oh, 1 second, guys. You don't want to hear me cough into the microphone, so. Okay, Europe started to move mid-range 4s. And I would even say that's even if you combine them together, it equals upper 4 or upper 4 to 5. 4.8 plus 4.3 plus 4.3 is certainly taking us to right at the 5.0 combined threshold between all the earthquakes in the day. This is in a day's time, pretty much. Maybe 2 days. But this movement, let's show you where it is. Again, an earthquake south of Crete. This is the Isle of Crete right here. And then the others are striking on land at the Ionia Range. That should ring a few bells for my longtime viewers. Let me show you what's there. So first of all, what's south of Crete? Do you see it? The USGS marked plate boundary. That's where the earthquake is. The other earthquake striking up here in central Greece at the Ionia Range. And see where it says central Greece? And let me see if I can turn on our base maps and get a satellite terrain view. There we are. Okay. This is going to help us a little bit. Again, the Ionia Range. Ionia. Well, we get in here, and this spot right through here shifted several years ago. There were thousands of small and moderate-sized 4 and maybe even going up to 5.0 earthquake. Certainly thousands of 2s and 3s, hundreds of 4s and 5s struck here. Went on for days after days after days right at the Ionia Range. I promptly issued an earthquake warning for the area downstream from that event. And let me take you back over here to the USGS map, where the red lines are. And the earthquake swarm happened right here at the Ionian Sea at the Ionia mountain range. And the warning I issued was for down here in Italy, actually up in North Italy. You see where the red line goes? It goes back up to the north, goes right up and dead ends into the Swiss Alps. This was many years ago. I want to say it was 5-6 years ago. It was before I was live streaming. And what happened was the earthquakes built up at this location. And then like a dam, one day, after many days of breaking, it broke free and went right up into the end of the plate boundary and slammed into the end of the plate boundary at the Swiss Alps. And so it was like a pinball game where you pull back the spring to hit the ball and it goes down the track. And that's what happened again several years ago. Well, now we are back at it. We're right next to it. Now, they found those years ago, I want to say maybe 2 or 3 months after that all happened, they found out that the mountain range itself had shifted to like 10 centimeters or so. It was a huge shift, and it wasn't just one spot. It was the whole area had shifted like 10 centimeters on the plate boundary. And again, the plate boundary is the red line from the USGS here. All right, and that's happening now. New 4s are striking here, but they're not hundreds of them. Only a handful. So it's way, way less. It's still a lot of energy going on. You got to remember, you had your 7.0 earthquake here last week. We're looking for a 5.7 to strike back up here at Croatia to Bosnia. So far, it's gone up to 3. I think the highest it actually went yesterday was near 4. It was upper 3.0 level, near 4.0, just struck yesterday in Croatia. I hope that's all we see. I hope I'm a magnitude under across the board. But hope in science, we wait till the end of the forecast, which is 2 more days, 48 hours more to go in the forecast. Energy went up across Switzerland and out into central France. And we have an earthquake out here at the western portion of France. But it's just a small 3. Most people wouldn't even think much about it. But the spread is what we're looking for, and look what went out to the Azores. Also a 3 and a 3.2. So they're about the same size. Energy going out from Europe, out to the Azores. Let me show you on the USGS map here. Out from France, out to the Azores. The Azores are right here at the T intersection of the plate boundaries that go back across Spain. And what happened in Spain? Look. So out of France, down through Spain, over to the dead end. We put a 3 in, we go down and around the bend, and we get a 3 out. It's not much loss of energy, is it? Meanwhile, after Poland got hit a day and a half ago, we have new activity up at Norway, which Norway is a long story on Norway, but we're still moving in Iceland. It's actually spread just a little bit, about 100 miles off the coast. We're spreading out. That's good news, I think. I would think it's good news that it's spreading out across the plate boundary as opposed to just focusing in on the spot that they're looking for that possible eruption to take place. I'm still talking about that as possible. They think it's going to happen imminently. We're watching and waiting for that to take place either way. So where should we start here? Let's start in South America. First of all, like bookends on either side of South America, we have a 5.1 and another 5.1. If we take those two and add them together, it equals 5.2. Why does that matter? In between them, we have a 5.2, the cumulative total. But first, the 5.2 struck. So first, the one in the middle struck. Then these two on the outside edge struck. And then, in between them, an equally spaced series of 4s, filling in the middle points of each other and the middle points, the halfway points, the fulcrum points, in between the other 5s. And that's all happened since yesterday. That's a change from where we were. We were at 4s. We've now taken a step up to 5s. So the energy's finally taken. It's taken 5 days. We have 2 more days to go on the watch. It's taken 5 days to saturate South America. And now it is. It's there. It's in the 5 range. I would look between our 5s for our new sets of activity to break out where all our 5s and 4s are. You see where the rings overlap. Travels underneath point. The rings overlap all up here, right at North Chile, right at the Argentina-Bolivia border region. And the rings overlap here. 3 spots. All 3 are going to get hit. Oh, the third spot where it overlaps is at South Peru, right where north of Sabancaya volcano. So something's going to break out in between this hot mess of seismic activity. Something bigger than what's on all sides right now. We combine it all together, something bigger hits in the middle. And that's where we're looking for 7 to hit. So far, again, we're at 5s. So we're 2 magnitudes under with the big quakes, 1 magnitude under for the small quakes. In other words, we're a whole step lower than I was expecting. Which is good, I guess. All the spots are getting hit perfectly. So triangulating the points and the halfway point and all that good stuff that we do with forecasting is applying in this. But the magnitudes, the amplitude behind it, it's like the volume knob is just a little bit lower than I was expecting it to be. 1 to 2 magnitudes. Again, when it comes to the big earthquakes, being 2 magnitudes under is just like being 1 magnitude under on the small quakes. It's a step less. Now look what happened up to the north. Do you notice anything up to the north? We're looking at 48 hours worth of earthquakes. Do you notice anything? Well, here, let's make sure that's 48. Here is 48 hours worth of 4s. So I'm seeing something missing here all the way across Alaska, Canada, the west coast of the United States, the west coast of Mexico, and also the west coast of southern Central America going into South America. I'm noticing a lack of seismic reporting. Or it could be a legitimate lack of earthquakes. It could be. If it is a lack of earthquakes, we are building into something then. Something big on the east side of the Pacific. So I hope they're just not reporting the quakes for some reason out of the East Pacific, but let's just look at it. So from central Peru, where our 5 is, our bookend, by the way, again, the bookends on both sides of South America, right? So beyond the bookend up to the north, it's gone quiet. Just beyond our halfway point up here, the northern arm is what we'd expect to shift. We expect the equivalent of everything in South America down to the south to also be represented up to the north. And when it's out of balance like this, from central to the south, then we would look to the central to the north for a new break to take place. And you'll also notice the distance between these 4s up here along the coast of Mexico and Guatemala is about the distance that we would go all the way down to the south. Do you see that? Down to the south and around to the South Sandwich Islands, I mean. So all the way down to the X, that distance is about the distance all the way up to the north to the 4.7, which I would call that the end point. Getting back to the plate boundary map one more time is going to make sense in about 2 seconds, okay? Let me back it out ever so slightly. So over to the east here is about the same distance down to here as this is down to here. We're talking about the same distance apart if we go around the bends of the plate. Equal distribution is trying to take place, but to see it, we have to back it out a planet away. Now, on the north side of here, we have a 4.7 that struck yesterday. 4.7, a 4.1. They both struck within the same day, a day and a half ago, back on the 7th. Well, actually, that's 3 days ago. 72 hours ago, these red earthquakes struck. Yesterday going into today, a 4.8 and a 4.1 struck. What's the difference between the two? What's the difference between a 4.7 and a 4.1 and a 4.8 and a 4.1? Not much. That's what I'm getting at. It's a point, hair of a point of a difference. But why are they related? They are related. These two struck first, plus some volcanic activity over here at Guatemala 3 days ago, and then energy transferred over and across, and we get the same amount of energy coming out of the system that we put in. Again, the volcanic blasts add into that. So if we get a few blasts here, along with some 4s, all of a sudden, same-sized activity breaks out over here to the east, seismically speaking. And that's what's taking place now. This somewhat fulfills my forecast for the Eastern Caribbean as well. And again, we're a magnitude under. We were looking for upper 5, and we get an upper 4. 1 magnitude less energy across the board everywhere. But a bunch of new deep earthquakes hammering in on the underside of the plate right now, indicating something's getting ready to happen in the West Pacific again, on top of everything else that's already happened. Now let's take it down to 3s, and you're going to see a path of earthquakes leading from where Vaniaminoff volcano is erupting up here on the Alaska Peninsula, and 3s going all the way into Mount Denali, and 3s going all the way up to the northern slopes of Alaska at the Arctic Circle, east of the pumping operations up here next to Prudhoe Bay. 2 2.9s, we'll call them 2 3s. How about another 2.9? Let's go look at all the 2.0s and greater just to add in the rest. And if we add in 0s and 1s, it's almost too much to see. So we're going to look at the 2s and greaters right now. And it's all the same size once we get north of Mount Denali. Mount Denali's at the bend in the plate here. And then what do we have at Mount Denali? Do you see it? It's mixed in with the rest of these. A 2.9 to 3.0. So wait a second. 2.9 to 3.0 at Mount Denali. 2.9 to 3.0 out here north of Mount Denali. 2.9 to 3.0 up here at the northern slopes. It's all of Alaska has just moved on a 2.9 basis in a day. How much energy do you think it would take to displace all of Alaska in a day's time on a 3.0 basis? That's the way you need to look at this. So while they look like small earthquakes, and yeah, they are, it's the whole dang plate on the edge of the craton that just shifted on a 3.0 basis in 24 hours' time. Maybe 48 if you want to get into international time. Okay? Now back out here, we have a blast to top it all off, which is somewhat rare. I've got a warning going in the middle of the Aleutians, expires in 2 days. Warnings that expire in 2 days. How about the west coast of the United States? So we're getting down to it, and the spread that I'm looking for is 1 magnitude under so far. That should stand to reason it probably will take place the same way in the United States. So instead of seeing an upper 5 to 6, we'll see an upper 4 to 5 out off the coast of Eureka. And then instead of seeing a 5 down in Southern California, we'll see a 4 down in Southern California. If I'm 1 magnitude under across the board, it will hold true in the United States as well. Now let's go and look at the last 24 hours worth of earthquakes in the U.S. This is going to give us a good idea of the areas that have currently moved the past day. Now what you'll see in the center of the United States is one of the bigger earthquakes of the day so far, which is a 3 right in the middle of the plate, right in the middle of the craton. And this is in a pumping operation in Oklahoma. Oil and gas, fracking. Same with the 2.7 down in Texas, but both of these are on the edge of the craton. Let's pull the coordinates. 3.0, Oklahoma. Oh wait, that's coming from the Europeans say it's a 3. The USGS has properly weighed in on this and taken it down to 2.7. Coordinates, paste, and search. Always fun. Get to see what's there. For new people, you've probably never seen this. So here is the earthquake epicenter. Looking down on it, you see the square grid of the roads, but when you go into the square grid, you're going to see all these little square pads that are cut out of the farm fields. And they have gravel on them. You'll see tanks, pumps, jacks, and pipelines. Here's a Derek and a team of people out there doing work in 2019. Looks like they have several going. Look at that. They're drilling at all 3 locations in 2019. And every one of these little square pads is a different pumping operation. You start to make out that there's so many of them all over the place. This is just a few hundred right around this alone. All these little square things here. So we're dealing with 500,000 or more different drill points in Oklahoma, and we're dealing with fracking. Same with the 1.9 up here. I'm not going to take the time to look everyone up. You guys can go look up the 1.9. And Texas, this is well known. Texas has millions of drill points, especially down in southwest Texas right at the border. And I can just randomly zoom in on that area, and you'll see what I'm talking about here. It's not even up for dispute by anyone. Right down here at the border region, we have tens of thousands of drill points. Just like what I was showing you in Oklahoma with the little pads, but you see how many there are. Okay, we just go on and on and on, and they have some that are just into what I would call excessive overdrive. All these oil pads here. Hopefully you can see them on the screen. Here's a town, for instance. Here's what a town looks like. And here's what the oil pads around town look like. Anyway, they've done all counties down there that way, to the point, again, where we're dealing with millions of drill points down here. And that's on the edge of the craton in the south. Look at Texas. Okay. And the earthquakes go down the edge of the craton and reach out to these spots that are weak points, whether they're Mother Nature made like a volcano, or whether humans come in and drill. Mother Nature doesn't care. She seeks out those weak points in the plate. They only have to be a few hundred to a few thousand feet long. The weak points that are created. Like perforations in a piece of stone. You guys ever score a piece of stone? Score a piece of granite even. Thick granite, multi-layer granite. You can still score the piece of stone. Apply pressure on one side of it and watch it break at the score point. Now this is the plate. This is supposedly miles and miles and miles thick or more. And we're talking about the same process taking place, where scoring takes place on the surface, in this case, millions of drill points, and then Mother Nature pushes on the edge of the plate from over in California and the West Coast, and next thing you know, the craton shifts, and the energy follows that craton edge, and you've drilled on it. Okay, let's go over on the West Coast, start up in the Pacific Northwest. Before we go any further, we need to go check the Pacific Northwest Seismic Network Tremor Map. See what it shows. 275, I dare say, old boy. 275 tremors. Well, that's an increase from where we were. Let's go back a day. Let's go back to the 8th. 19. Northwest Oregon and in the Valley of California, Northwest Valley of California. But look, the 9th, boom. We started to break out with a new outbreak with hundreds of tremors in Southwest Oregon and hundreds of tremors here in the northwest tip of the valley. Now this spot and this spot correspond to spots out in the ocean. Let me show them to you. Out in the ocean is the Juan de Fuca fracture zone, which we can even see on the USGS plate boundary map here. It's the jagged edges out in the ocean. And the southern arm here, where this jagged edge, this looks like an arrow pointing in, doesn't it? And down here at the Mendocino Fault, going into the Gorda Escarpment and down into California, this is the San Andreas. San Andreas ties in right down here and starts. So wait a second. Look where we are. This is like an arrow pointing right into the spot that's shifting on land. And the Mendocino Ridge Gorda Escarpment goes in and goes down to the south into the San Andreas, right where they meet on the interior portion of the plate. Rumble, rumble. Each one does have a magnitude assigned to it, but it's not really an earthquake. It's not fracturing in a fault. It's the whole area shifting miles across, vibrating down below as the plate is slowly moving. So the way I want you to look at these is these are up above this. And this out in the ocean is pushing in and up into the plate. So think of this like a bathtub or putting your feet into a pool. That this is the edge of the pool, and you would put your feet down to the bottom of the pool or dangle them in, right? Okay. But this is the top side of the pool, and we are at the bottom pushing up into the side. And up in here is where the vibrating is happening. And when that starts to shift, the areas around it start to shift. If we start to shift here on land and vibrate, what do you think happens down to the south in the San Andreas and up to the north in the Cascadia subduction zone and over to the east all the way to Yellowstone? The craton starts to move, of course. And that's what's going to happen in the next few days as a result of this now taking place in Northern California. We are watching for a 5-point-something earthquake to break out right here on the coast. Let's go back to the tremor map. Again, I've got a warning going for a 5-point-something earthquake to take place right at Eureka, and Eureka is right here. People ask me about the grid shape on the ground. That's due to the, let me click on one decimal point or two on latitude and longitude. Okay. All right, so in the middle of the area where the two shifts are happening, that's where we got the warning for the 5 going. It's not a coincidence. That's the area that's shifting now. We expect some new seismic to accompany that very soon, going down into California. Now, up in Northern California, we have some more rare earthquake activity. Let's go pull this 1.5 up into place 3 kilometers west of Edgewood, California. What is up in there? Let's go see. I hardly ever have to look at this location. Well, wait, it's shifting. I just showed it to you, duh. I just showed it to you. Wait, what is this volcano here? That's Mount Shasta. Isn't that wonderful? So the location here, Mount Shasta, the nearest town is called Edgewood. That's right. All right. Okay, funny story. A few years ago, we were looking at earthquakes up in here, and I think it was right up here in these lava flows. Yeah, that's where it was. There was an earthquake up here in these old lava flows. And I zoomed in, I was like, what are they doing out there? Like, geothermal is what I thought. I thought it was a geothermal pumping operation. And when I zoomed in on it, I realized pretty quick what I was looking at. And I just got the biggest kick out of it. I thought it was so funny finding that there. Because the town right next to it is called that. Okay, anyway. Funny story. Don't go out there, kids. Yeah, that's authorized by the state, guys. Come on. All right, so we go down there. We got a 1.5 that's right next to Mount Shasta, the volcano there. So that's the stratovolcano. Of course, the earthquake is related to the volcano right next to it. What about the 0.9 over here at Manton, California? 8 kilometers southwest of Manton. Put the coordinate. Yeah, guys, you get a kick out of that. Hey, we can all go out to California. I'm down for that. I'll never come back. Here we are, right next to the Inskip Volcanic Buttes. But you also notice something going right through the volcanoes themselves. Quite literally right on the side of them. We've got a series of high voltage transmission lines, which definitely plays into seismic activity. We've demonstrated that enough. So wait, we got a volcano and power lines now? Oh man. So we're shifting up here. I just showed it to you. North Valley going up to Northern California, all vibrating as the plate is shifting. We have an earthquake up here next to Mount Shasta. We have another earthquake at Inskip Volcanic Buttes next to the power lines. What about the 2.5? Europeans say it's a 2.5. USGS begs to differ. Oh, no, no, no. It's a 2.4. But you click on it, and it says 2.5, because that's just the way they do it. Makes no sense. Does that make sense? They didn't adjust their feed. They just changed it on the page. That's hilarious. Okay, here we are. Where are we? We're right next to where all the fires broke out this past year. You remember when all that happened? So fires broke out in September, and I have them still marked here because it was worth remembering. Back in September, major fires suddenly broke out here on a clear day. People saw lightning bolts coming out of the ground. They took pictures of it. You remember? They tried to blame it on a lightning storm. Over to the west, a 1.9. We don't even need to look up where it is. It's on the edge of the Gorda Escarpment coming into the plate boundary. One more time, we got all those tremors happening there, but here, right where it comes in, that's where the new earthquake is. We get down to the south and we're at the geysers of California. And when you go click on the coordinates or put them in on Google Earth, you're going to find another volcano. If you're a new viewer, if you're a longtime viewer, you've seen this probably thousands of times now. So, wait, hold on. Make sure you guys can hear me. So here we are. We're at the geothermal pumping operations. Number 7 and 8, apparently. They're generating high voltage electricity. So they're generating a lot of electricity with those geothermal turbines from the steam from this volcanic field, Clear Lake. They drilled into the side of it. Now there's faults there, but the reason there's seismic there, it's right along the fault. The plate's shifting there. They drilled there. And Mother Nature punched up through the plate there as well. Down to the south, 1.1, 1.5, 1.1. The 1.1s are like bookends. The 1.5 in the middle. This is on the creeping section of the San Andreas, east of Monterey Bay. Now, just a day ago, we had a hot spot here. Now we start to shift. Hot spots shifting. Let's go down and take a look and see what's there now. They still have a hot spot there? No. Okay, well, the hot spots are gone, but now the earthquakes return, and they go in a line, equally spaced, down the creeping section, and then, whoa, a 2.7. Pretty much the biggest of the bunch in all of Northern California. Look where it struck. Here. South of Dos Palos, California, huh? 23 kilometers south. Well, there's probably something there nearby. Wait till you see what's there. Here is the earthquake epicenter in the middle of some farm fields. What do we have going on there? Okay, that's for farming. Oh, wait. I see a few things here. First of all, I see high voltage power lines going right through the area. And these are not the kind that go to your house. These are the huge towers. 3 sets of them. That's right where the earthquake struck, huh? What is this over here? Oh, another set of them. And this is 4 sets. 1, 2, 3, 4. So we have 4 sets on one side, 3 sets on the other. And what is this in the middle? A road. Well, what would you do if I told you there's something else there nearby that's pretty interesting? A bunch of frac wells on the south side of here. So we start at this location. We have oil and gas. Do you see it? See the tanks, the pumps, the jacks? They go across the fields here. They're drilling, and they're getting oil and gas. You can even see the shadow of the jack of the pump there. Drilling. So they're drilling just starting there. Once we get to the south, we get to tens of thousands of drill points that I showed you in yesterday's update. Oil and gas all the way along the San Andreas that they drilled in to get. Well, the earthquakes are right on the north side, right where all the power lines come together. Nobody can tell me that's chance or coincidence, and I wouldn't be surprised if there's oil wells also nestled out in here somewhere, intermittently spaced throughout all of this, but I don't have any place marks for them, so for the time being, we're just a few miles from them. It's the biggest earthquake of the bunch. Over next to the pumping ops, over next to the power lines. And it's not like there's high voltage power lines everywhere. They just aren't. Over to the east, we go over to the east side of the valley. We have a 1.7, and again, this is in the valley, not over at the supervolcano. We're at Shaver Lake. Do you remember what happened at Shaver Lake? A massive fire broke out at Shaver Lake this past year, leading me to investigate around the area to find these giant laccoliths that I was just shocked to find over in the eastern valley of California. Shaver Lake is right here. This is Shaver Lake, and this is what drew my eye. You see, it almost looks like a landslide, the way this is all flow-like back up to the top of Shaver Lake. Well, it's just the side of a laccolith, and there's others nearby to prove it, like this one here. Maybe you can see it. Hopefully you can. Do you see it? It's a mound. Again, that is not a mountain. Well, I mean, I guess it technically is a mountain, but it's a bulge in the plate created by magma intrusion. There's another one down here to the south. So I just showed this one to you here. And right down here, this one. And again, it bulges up to the center. It's pretty obvious. And it's not just a standard mountain. But the fire broke out on the side of Shaver Lake, which itself is just like a formation we've seen, for instance, over in Iran, which I showed in my past updates already. We're not going to waste too much more time on that. It's just a 1.7. We get over here, we have 3 earthquakes, which is low. We've seen hundreds, if not thousands, of earthquakes happen at this location before. This is a supervolcano called Long Valley Caldera. Also known as Mammoth Lakes or Mammoth Mountain, it's a ski resort. It's kind of like Dante's Peak. Beautiful. Absolutely beautiful. And I mean, I'm not joking. Absolutely fabulous out here, guys. But you're on the edge of a supervolcano. Here is the supervolcano, Long Valley Caldera. Click on it. Read the Smithsonian if you need to. There's Mammoth Mountain, the ski resort. And it's a separate volcano on the side of the supervolcano. Okay, and that's where the earthquake's happening right next to. Again, think of this like Yellowstone. You get an earthquake right outside the park in Yellowstone. It's related to Yellowstone. Going across the border over into Nevada, we have a series of small earthquakes still breaking out in Mina, Nevada, but the number of quakes here is dramatically low. We're expecting 5s to come into California, and so far it's gone hush, hush. But something else happened out here yesterday. You guys remember in my last update 2 days ago, there were a bunch of hot spots all the way across this salty basin. And it wasn't from the sun shining back up or anything like that. Centered around here, they're all gone now. All of them. So whatever it was, gone in a day. I would say heat release from the plate or some kind of electrical interference from the plate. Now our new earthquakes happening here, same spot that the hot spots were yesterday. But they carry on every day, so you can't say they're directly related. But I would say the hot spots are related to the location as opposed to the earthquakes that are happening there now being somehow related to the hot spots. Again, this has been happening every day. This number is low, way low. And I mean big time low. It's a handful of quakes when we normally are dealing with dozens, if not hundreds. As we go down to the south, let's go look these up. 0.9 down at a place called Goldfield, Nevada. Well, there's something out here next to Goldfield. First of all, the Ubehebe craters are on the California side of the border right here. Let me show you. Here's the Ubehebe craters. They had hotspots inside the craters a day and a half, 2 days ago. Inside the Ubehebe craters, hotspots. New earthquake striking right up here next to Obsidian Butte, which is really just a part of the complex. And when you look at it, to me, it doesn't even look like a volcano. But it has some tuftage, I guess, exposed on the side, but it's such a low resolution image. Kind of hard to tell anyway. What do we have going on up here? Well, that's really interesting. Maybe some kind of military? Look at that. Goes right through the mountains. What is all this? Oh, yeah. Oh, yeah, we got military. Look at those tanks out there. All right. Tank target practice test range. What's all this? Wow. Look at all those tanks. Armored personnel carriers. Is that like a graveyard, or is that where they are actually driving them? Well, there it is. We're on the other side of a huge military. Is this some kind of explosion that I just don't know about? No, is it 7-kilometer depth? Got a little seismic over there right next to it all. Very interesting. What about down to the south? This 0.9, 1.3, Beatty, Nevada. Beatty. I think it's Beatty. Out in Nevada, though, what is going on down here? We're leaving a military tank test site. Well, I don't have much better news for you guys because I already know what's here. First of all, awesome volcanic rock formations from forever ago. Look at that. That is volcanic rock. And these are volcanoes on the edge of the nuclear test sites. Skull Mountain, Doom Town, Operation Rise Line right here. And then all the underground nuke test sites with all the craters that get left behind. And we can turn on the Google Earth community again and just randomly click on one of these nuke sites, get the info on it. What's this one? Wow, there's, okay, Rise Line again. You see the names on these? We can maybe click on one here. Hold on, let's find one that's clickable. U.S. Nuke Operation Hermosa, April 2nd, 1985, 20 to 150 kilotons. Just one of hundreds that are through that valley. The earthquake's on the south side of the valley, but the nuke test sites that we did with France and the UK, all over here. So just giving an example, all of these going down to here, the French and UK. Close enough for me. We're definitely on the edge of the nuke test sites. Man-made faults is what we should call those. Before we get out of Nevada, let's go look up this last earthquake, which is a 2.6 down by Alamo, Nevada, 9.5 kilometer depth. That's kind of the same energy that came rolling in, isn't it? Got a 2.6 all the way down here, and we put in with a 2.7 over in California. They're almost parallel to each other, too. They're like bookends. But paste and search. Let's go see what's there. You got to do this. You almost have to do this yourself. Start looking up the quakes. It's addicting. Once you start finding stuff, you'll never look back. You'll always say, wow, I'm so glad I started to look this stuff up. Ranchers. Look at that fissure or that ridge. That's a fissure. That's an old fissure. Salt bed, Salt Lake carries on. Looks like a fault. What's down here? Wait. Look at that. Out in the middle of nowhere. We have high voltage power lines literally going through that salt flat desert. And they're the huge kind. Look at that. Look how big those are. That's massive. Those are massive. Do you see those? Look how many tie downs those are like 1,000-footers. I wonder if we have a street level on this. Dang, no street level. All right. Well, massive high voltage power lines, the biggest I've ever seen. Okay. That again, you'd have to tell me that's coincidence. And coincidence ceases to be coincidence when it happens all the time. Just saying. Now let's go up here into Utah really quick. Go look up the lone earthquake out at Clear Creek, Utah. One quake, negative 3.4 kilometer depth. We're up inside of a mountain. We're above sea level, up inside of a mountain apparently. Let's go see what's there. That's how you get a negative kilometer depth earthquake. Oh yeah, we're definitely up in a mountain. What do we have here? A little community of some kind. Small little community. Clear Creek. Mount Pleasant. Oh wait, I know what's right here. It's not so pleasant right over at the bottom of this hill. Starting right down here at the bottom of this foothill, we have a series of oil and gas pumping operations. And you can see the shadow of the jack of the pump on this one. There's no doubt about that. And all of these little pads, this one and this one and this one, backing it out, you'll see how many more there are. And this is sparse. Even though they're all over the place here, even though it's like when I back it out, you'll probably have a few hundred right through here. This is nothing. Goes on up over here, goes across the mountain range. Do you see them? Nestled into the mountain range. And then on the other side of that range, we go through there, and right over here, all of this is drilled. But it's kind of an optical illusion when you look from above. Look at that. Look how many there are. And we just keep going and going and going. And everyone's an oil well or a gas well. And we go down into the fields where they become a little bit more easy to see. But they look like a grid on the ground. There's so many. They go right across the farm fields. Right through the farms. And they pick up on the other side with even more. And then you get down here and it goes crazy. And I mean, they have so many through here. Do you see all the little white splotches? Everyone's a different oil well. Now, that's a lot, right? The reason I take the time to show this to you is most people don't understand how many different drill points there are. So you get all the way back down over here, you get on the edge of that drill point. Again, if they start pretty much right here and go all the way around here, this is the edge of the drill point. That's the edge of the perforation point that's getting hit. Up to the north, we're in Yellowstone, where the number of earthquakes, actual quakes, are starting to increase. They're actually starting to go up actual fractures above the magma chamber at Yellowstone. So that's a change. Edge of the Craton is still moving in Montana, and we still have a few small earthquakes over in Idaho above the deepest part of the Yellowstone magma chamber. All this is low. All this is low. One earthquake out here in the middle of Oregon. Let's go look. La Pine, Oregon. It's very rare for us to get any earthquakes reported out of Oregon. They actually have it listed as a negative 0.1 earthquake. A negative quake. I guess it sucked in power. We don't have an earthquake there. It's actually sucking in power. Uh-oh. If it's sucking in power there, we've got a real problem because we're at the Newberry Crater itself. Inside of Newberry Crater, you can read the Smithsonian on it if you need to, but it's well known. It's right in the middle of Oregon, and we got a negative quake there. I'll call it a positive quake. These are all lava flows. I'll call it a positive quake, and that the negative calculation on that is just incorrect. Up here to the north, the predominance of the quakes in Washington. Oh, it's Washington? Washington. Okay. In Washington, we'll put the coordinates in. And we're just going to go look up the cluster. We're not going to look up every earthquake in Washington. Look where we are. The foot of Mount Rainier. What's the difference between this and my last update? Last update, we were on the flank or the side of Mount Rainier. Now we're at the foot. Last week, we were up at the crater, down below the crater. So crater, flank, or side of, and foot of. All moving in the past week. Small earthquakes. But a sign that the magma chamber is being slightly perturbed. Up to the north, 0.4. Waterville, Washington. It's not an explosion this time, right? Or was it last time? Oh, was it? Oh, I don't know. Getting my fuses crossed here. My wires are crossed, blowing the fuse. Wait, hotspot. We've got a lone hotspot out here in Washington. What is going on there? Computer's filtering it out, doesn't know what to make of it. One lone hotspot. Now let's put the coordinates in and see how far more north we need to go. Oh man, look where we are. We're right next to the high voltage power lines again, right across the river. Is that close enough? I don't know if that's... I honestly don't know if that's going to be close enough to be related. It's just coincidence they're right there. That would be just coincidence. That's like miles away. What's up here at Chelan Falls? Oh, watch us have like some kind of nuclear reactor up here. I wouldn't put it past them. Would not put it past them. Okay, we don't know, so I'm not going to guess. Must be fault nearby. Let's go click on the USGS fault information for Waterville. See if they have any marked faults. No marked faults. No marked faults. No nearby interesting features. Out in the middle of nowhere. What's going on? We're on the edge of the river. A basin. Palisades. Am I missing anything? Maybe I'm missing something. Somebody needs to let me know. Maybe it is the high voltage power lines and it's just a few miles away. That's getting into speculation on my part, though, big time. What are down at the little quarry? Hey, wait a second. They're quarrying. You got prospectors quarrying out here. That's a house blasting in. Maybe it was. Maybe it's an unlabeled explosion. Do we have 3 farms there? Somebody could be doing some digging or some blasting. It could be. But we have a lone hotspot out there. That's not really that interesting. The earthquake. But the hotspot is. What about this one over here? We've got a lone hotspot all the way at the state line. Right at the state line. This looks like some kind of ski resort. You think that's what it would be? Mount Spokane? Spokane? What if this is an actual fire? No, it's being filtered out by the computer as not knowing what to make of it. Another spot where heat's being released and the computer doesn't know what to do. Okay, as we wrap this up, let's get into Southern California, quickly run it down, since most people are aware of what's down here. We have a series of volcanoes out here at Ridgecrest, and a line of quakes that has not stopped since you got hit by your 7 almost 2 years ago. And this big movement that keeps taking place is dependent on what's coming in from the north. Right now, what's coming in from the north looks pretty small, but don't let the looks be deceiving. We've got the plate shifting right now. Again, getting back to the United States, start of the update broadcast for the United States here. We are shifting, vibrating. PNSN showing us the tremors, hundreds of them. California going up into Oregon, which means we are about ready to move in California. Things are about to go up in California. Every time we see this thing move, not every time. 9 out of 10 times we see this thing move up here, we see corresponding movement going down into California and all the way over to the east along the edge of the Craton, all the way to the east coast. And that the Craton shifts all the way from the west coast to the east coast when the plate shifts. You can't move here without moving the rest of all this. And that's why it's so big when it breaks. Down to the south we go, and we watch in the south tip of the valley down to Southern California. I would like to go look up the earthquakes in the LA basin. We didn't have any a day ago. Now we're back in North LA basin. Isn't there something here up in North LA? I mean, how many times are we going to have to go back here? But let's go see how close we are. North LA starts moving. You got to look where. Where is it moving? Well, San Fernando Valley. We've got ourselves a flood control basin. That's going to be, again, that's a basin that's formed there. That has nothing to do with the quakes. The things that have to do with the quakes would maybe be up on the north side of the basin. All of this, Aliso Canyon. Now wait, last week we were on the west side of Aliso Canyon. This week we're on the east side of Aliso Canyon. Aliso Canyon being the middle point between our quake here and last week's quakes over here where the oil wells were. So Aliso Canyon's a gas storage location, fracked out, drilled out, where they stored gas, and it blew up a few years ago. When I see earthquakes around this at all, I have to watch real close. When I look in here, though, I just wonder, are there any drill points here nearby, or were there any in the past? There might still be oil wells functional here along the side roads. I'd have to do a thorough inspection for a small earthquake. I'm just not going to do it. But it is close enough, again, to the other pumping operations, or to current ones that currently exist that are just well masked. Definitely would be related. Have to go look. That's the only way you find out. 1.5 down to the east by southeast at Charter Oak, California. Some of my viewers might live right down here. I got a letter from somebody in Charter Oak once. Well, maybe they're watching. They'll be like, there's my house. Dude, I live right there. All right, there we are. South of San Dimas. Now, I don't have any marked pumping operations at San Dimas, but just south of San Dimas we do. We've got a lot of them. They're all over the hillsides down here, and they're numbering in the dozens of wells per hilltop. It goes on and on and on. Again, we got a big pumping operation there, and it goes all the way down to here. That's miles across. Now, I always look 6 to 10 miles. This looks like it's further than that. So I don't know if this is going to be far enough away to not be related. Nope. 9 miles. The reason I look for 6 to 10 miles, they can drill out by many miles at an angle or even horizontally. They can drill up and down vertically, we all know that, but they can turn that now sideways and drill sideways by many miles. Glad I checked. And there might be some here on the north side or old drill points here, right around where the earthquake is, and I'm just missing it. That's where the other earthquake is, the 1.5. The other 1.5, down to the east by southeast. Home Gardens. Oh, wait, it's a quarry blast. Never mind. We can just skip that, right? Oh, wait, it's the same size as the earthquake. And they're connected along a fault system? Gee, I wonder if they're related. The other earthquakes are going directly across the San Andreas. Nobody needs me to explain to them about Southern California and the San Andreas, do I? Do you want to see the shape of it? That's the shape the earthquakes are taking, going down the San Andreas this way. Once we get down to the very southern part of California, we split 3 ways, like a 3-pronged fork, if you will. And the middle part of that is the San Jacinto Fault, which is lit up with small earthquakes. Once we get down to the south portion of California, very far south, we're on the south side of Salton Sea. South side of Salton Sea. What's there? Nyland, California? Nyland? Put the coordinates in and see. I already know it's there. Longtime viewers already know it's at the south side of Salton Sea. At the south side of Salton Sea are the Salton Buttes. That's a lot of S-ing going on there, but Salton Buttes are drilled. The Salton Butte volcanoes are old, but they've been drilled into to get steam, to turn the turbines. So what does this earthquake down here at the far south tip of California have in common with these earthquakes up here in Northern California? They're both a geothermal. We go over to the east, and a majority of these earthquakes over on the eastern portion of California going down into Nevada are either at volcanoes or man-made punch points like nuclear test sites and military test ranges. But they're not having explosions at the military test range. It's an earthquake 7 kilometers down below. The earthquakes in the valley, right next to the Lacolith. The earthquakes at the western portion of the valley, right next to the pumping operations. I didn't look up the 1.1, but down at the south tip of the valley, there's a series of quarries, power generation plants, and drill points. So they're all within a mile of each other. There's no way to determine which one's causing it. But they're all on a fault that connects into northern LA, which is starting to move next to, or at least close by enough to be related possibly to, our pumping operations. One quarry blast in the middle of it all, please. Then we get down to the south and we go down to the volcano down to the south. Same thing for all the way up here to the north. Volcano in Central Oregon. Volcano here, Mount Rainier, in Washington. Unknown out here in the middle of nowhere, literally a microquake 0. And then we get over to the east and we're at Yellowstone. We get down here in Utah, we're at a pumping operation. Get down to Texas, we're at a pumping operation. Get back up to Oklahoma, we're at a pumping operation. I didn't look up this earthquake down in South Texas. Same thing, it's pumping. You can go look it up. 1.9 on the east coast. Edge of the Craton. The only one that's not directly at a volcano or a pumping operation. At least across the Midwest. Once we get to the west coast, again, that explains it all. It all goes back up to the northwest. That's starting to shift. I told you, slow slip would start to pick up by the end of this week. Now, is it going to carry on? I don't know. They might hit the off switch tomorrow. Or Mother Nature might hit the off switch tomorrow. But either way, we're here right now. We have hundreds of new tremors breaking out in between, literally on both sides of Eureka, California. And Eureka, California is right here. Let me zoom in. Whoops. Here's California. Eureka, California is right here. And the tremors are going right in Northern California at the border and right south of Eureka, putting it right in the middle of the whole hot mess. Amazing. All right. Perfect time for me to tell you now to have an earthquake plan. Hey, China's been hit. Hold on. Hey. It's the Dutch Fonz. Hey, guys. Look, a 4.1 has struck right next to our arrows. You remember yesterday, if you were in my chat room on Twitch, somebody asked about the deep earthquake on the western side of Japan. It was in the 4 range. And I told them whenever we see that happen, we watch over to the west for new activity to break out going across China, following our arrows, and heading over in the direction of western Nepal, North India, and Afghanistan. Now it's just a 4, but there it is. Energy starting to come across. So we get a 4's worth of energy down here, and we get a 4's worth of energy here. Both are heading this way, which will go this way, and then go this way, and then go this way out to the Mid-Atlantic Ridge and dead end out here at the Mid-Atlantic. Perfect example for you guys to see at the end of the update. When did that hit? Hold on. When did it hit? Because it looks like it's new. 1818 UTC, an hour and a half ago it hit. Who reported this? The EMSC and Geophone and the USGS. It says the USGS, but USGS isn't carrying the quake. It says get more info from the USGS. See, more information at. Let's go over. Latest earthquakes. USGS. I'm not seeing anything out there in China. This is today's quakes. It just hit in an hour ago. They're saying get it more info from the USGS. You go to the USGS. They ain't got it. They ain't got it. And I said ain't. It's the proper use. I'm from Missouri. We can say that here, y'all. Okay, 2 p.m. Central Time. Perfect time for me to save this and get this out on a video. One more time, you need to have an earthquake plan. You need to know what to do when an earthquake strikes. I tell you this all the time. Someday you'll listen. Someday you'll take it serious. You'll develop an emergency kit and put it away somewhere close so you can grab it at a moment's notice. Doesn't need to be laying out on the floor, but certainly don't go pack it away at the top of a closet somewhere. Have it ready to go and have a change of clothes, set of shoes, extra flashlight and batteries and so forth. I'm zooming in on Hawaii here, but there's not much more for me to add into Hawaii. Pahalo's still moving. We're still moving up at Mauna Loa, and we're still moving along the coast where the Middle East Rift Zone is. Kilauea is pretty quiet, which means something's getting ready to happen at one of these other locations. But that's another update entirely, my goodness gracious. We could spend an hour just talking about Hawaii. Aloha to you guys. If you want to get full updates on Hawaii, I seriously would go to the USGS. I hate, I'm not trying to flatter them or anything, but they've been pretty spot on in their coverage lately. And I think they'll tell you before anything gets ready to happen. Overall in Hawaii, we know the Middle East Rift Zone's refilling and it's displacing the other volcanoes. That's what's causing the other seismic. Now the only question is it going to cause some kind of eruption? And I have no answer for that. They don't have an answer for that. No one has an answer for that. We don't have past examples to go on in recorded history. Last time this all happened was like 200-something years ago, right after Hawaii was discovered. All right, 2:01 p.m. Central Time, saving it as a video. We're going to save it. That's not a threat. It's a promise. My trolls are like, oh, you are, huh? Much love to everybody over on Twitch chat. For those of you who are watching on YouTube, you are watching a pre-recorded, but it is always live. Over on Twitch, you're welcome to come over and check. They're telling me to recheck the Volcanic Ash Advisory Center. Recheck the Volcanic Ash Advisory Center. What am I looking for? What am I looking for on the VAAC from my chat room? Please tell me, guys, because it'll take... I'm looking at it right now, and it doesn't look like any different. So it still has Bagana and Sabancaya. I mean, did I miss a big blast? Is there a big blast on there somewhere? I don't know. We're live. We're live. Okay, San Cristobal. San Cristobal. I missed it? I missed San Cristobal? Let me go down the list. Hold on. There. Oh, dirt. There we go. I missed it. San Cristobal in Nicaragua. No bueno. Volcanic ash not observed in satellite, with partial weather clouds obscuring the view. No new eruptions received. No new reports received since the last update. That's what their update is. So let's go see what the last update is. 8,000 foot high blast. Wow. Well, okay, that does change things a little bit. I'm glad you guys were able to get in on that and tell me. See where our seismic is right here? The two only earthquakes happening right in next to Nicaragua. Technically, that's Costa Rica to the south. So we're on the south side of Nicaragua with our seismic activity. And the previous earthquake from a day and a half ago on the north side, look where the rings overlap. Hey, the rings overlap on Nicaragua where the new eruption is taking place. That is proof positive, again, about the fulcrum points coming under pressure. Whether it's seismic release or volcanic release, we may have just found out a way to forecast eruptions. Or at least to know areas to watch for possible eruptive activity to take place. I'm not trying to bite off more than I can chew, guys. I may have just committed myself to start forecasting volcanoes, but it's happened too many times. It's happened way too many times for it to be chance. Has anything else hit since starting my update? Let's go see. Yes, okay, that looks like it. Thank God. This is like turning into a never-ending update. Sometimes they can go on and on for an hour and a half, 2 hours, if things keep hitting as I'm talking. You guys got lucky today. Hope you're ready to have a good weekend, and I'll be back if anything else goes down. Much love. Peace out.